Hi there, everyone. My name is Dominique Santiago. I'm a part of Dr. G's Chemistry 1 laboratory class, and today I'm going to be talking about Experiment 10, Acid and Base Titration 2. So before we start, I do want to give a small introduction and compare and contrast primary and secondary standard, which we've seen those terms before. Primary standard would be an original or first reference, and a secondary standard would be a copy or replica of the primary standard. So for example, the primary standard would be a handwritten homework, and the secondary standard would be a scanned or printed copy of the handwritten homework. So today, I'm going to be showing you how to do some math, and we're going to solve a titration problem since we did not do that last time. So this is a problem straight from the lab notebook. During a titration, a student used 31.92 milliliters of sodium hydroxide solution to neutralize 30.0 milliliters of 0.2488 molarity oxalic acid solution. Remember that molarity would be the concentration of the oxalic acid. So for part A, we have to write the balance equation for the neutralization reaction. So we have to identify the formula of the compounds and the product of the reaction. So we have sodium hydroxide and oxalic acid. They both react and form Na2C2O4 in water. So when we balance the equation, remember that we need the same amount of hydrogens, carbons, oxygens, and sodium on both sides. So we would have to multiply the sodium hydroxide with a coefficient of 2, and then the water with a coefficient of 2 to get 4 hydrogens, 6 oxygens, 2 sodiums, and 2 carbons on both sides. So for part B, we have to figure out how many moles of oxalic acid were present in the sample. So we have to identify the volume of the oxalic acid, which is given to you in the problem, 30.0 milliliters. And then we have to convert those into liters. And how we do that, we would do 30.0 milliliters of oxalic acid times 1 liter of oxalic acid divided by 1,000 milliliters of oxalic acid, and we get 0.030 liters of oxalic acid. Then we have to multiply that by 0.2488 molarity of oxalic acid to get moles of oxalic acid. So we do the 0.030 liters of oxalic acid times 0.248 moles of oxalic acid divided by 1 liter of oxalic acid, and then we would get 0.007464 moles of oxalic acid. For part C, we have to figure out how many moles of sodium hydroxide were needed to neutralize the oxalic acid. So we would have to convert from moles of oxalic acid to moles of sodium hydroxide. So we would do our 0.007464 moles of oxalic acid times 2 moles of sodium hydroxide and 1 mole of oxalic acid, and we would get 0.014928 moles of sodium hydroxide. I got these from the coefficients of the formulas, if you're wondering. And then if we round that up, it would be 0.0149 moles of sodium hydroxide. For part D, we have to figure out the molar concentration of sodium hydroxide. So we would convert the 31.92 milliliters of sodium hydroxide to liters. We would do that by multiplying them by 1 liter of sodium hydroxide divided by 1,000 milliliters of sodium hydroxide, and we would get 0.03192 liters of sodium hydroxide. Then we have to calculate the molar concentration of sodium hydroxide, which is the molarity, and that would be 0.149 moles of sodium hydroxide divided by 0.03192 liters of sodium hydroxide. And whenever we divide those, we get 0.466668 molarity sodium hydroxide, and then that would equal to 0.5 molarity sodium hydroxide whenever we round that up. Thank you so much for watching. I hope this was helpful, and I'll see you next time.